CCI, Crash Course Instrumentation, presents episode number 14, Saturday Special, Simple Machines for Techs. Standing credit, thank you to Tony R. Kuphaldt and the open source community for the Model project. Hook. 6 simple machines built every tool you touch. Today, we'll tour levers, wheels and axles, pulleys, inclined planes, wedges and screws, what they do, why they save effort, and where you meet them in electrical and instrumentation work. Our roadmap. Work and efficiency, mechanical advantage, the 6 machines. Real shop examples, quick myths to avoid, wrap. And plain English terms, work, equal, force times distance, push something through a distance. Mechanical advantage, MA, output force divided by input force. Ideal MA, IMA, ignores friction. Actual MA, AMA, includes friction. Efficiency is AMA, IMA, a number less than 1 because friction steals energy. Lever, force trade with a pivot. Definition, a rigid bar turning about a fulcrum. Move the effort arm farther from the pivot to multiply force. Memory line, longer handle, less muscle. History bytes. Levers show up in prehistoric digging sticks and balance scales. Greek scholars like Archimedes, 3rd century BCE, formalized the lever law. Where you meet it, breaker bars, valve handles, panel door latches. Gotcha. Levers trade distance for force. You move farther. Wheel and axle, circular lever. Definition, a wheel rigidly fixed to a smaller axle. Rotation turns a long radius effort into higher torque at the axle. Memory line, big wheel, big torque. History bytes. The earliest solid wheels appear around 3500–3000 BCE in Mesopotamia. Spoked wheels followed in the 2nd millennium BCE, enabling lighter, faster motion. Where you meet it, valve hand wheels, winch drums, potentiometer knobs. Pulley, redirect and multiply. Definition, a grooved wheel and rope. A single fixed pulley just changes direction. A block and tackle with multiple moving pulleys multiplies force. Emma rule of thumb, count the load-bearing rope segments. History bytes. Simple pulleys were used in the ancient Near East. Compound pulleys are credited to Greek engineers, associated with Archimedes, 3rd century BCE, and spread through maritime rigging. Where you meet it, lifting panels, cable trays, hoist trolleys. Gotcha. More segments equals more friction. Efficiency drops fast without good sheaves and lubrication. Inclined plane, stretch the distance, shrink the effort. Definition, a ramp trading distance for force. A length of ramp or height. History bytes. Ramps are humanity's oldest heavy lift hack. Think Neolithic earthworks and Egyptian pyramid building. 3rd millennium BCE, where sleds on ramps traded long pulls for impossible lifts. Where you meet it, moving equipment on skids, slide-in racks. Gotcha. Friction can erase gains, rollers or sliders help. Wedge, moving ramp that splits material. Definition, 2 inclined planes, back-to-back that convert forward force into sideways force. History bytes. Stone wedges date to the Paleolithic, hundreds of thousands of years. Bronze and iron wedges sharpened the concept for carpentry and masonry in the Bronze and Iron Ages. Where you meet it, screwdrivers used as pry bars, don't, chisels, cable sheath strippers. Gotcha. Wedges, increase, side forces, mind what's behind the cut. Screw, ramp wrapped around a cylinder. Definition, an inclined plane spiraled into threads. Pitch is the distance advanced per turn. EMA, rough idea. Circumference of the handle, pitch. History bytes. The Archimedes screw, 3rd century BCE, lifted water with a helical surface. Metal screw fasteners spread in the Roman era and were standardized much later, 19th century, Whitworth in Britain, Sellers in the US. Where you meet it, terminal lugs, vices, clamp screws, jacks, pipe plugs. Gotcha. Friction is huge. Torque clamp force unless you follow the spec, dry versus lubricated. Quick MA sanity checks you can say out loud. Levers, double the handle, roughly half the effort, ignoring friction. Pulleys, twice the rope segments, roughly half the pull per segment. Ramps, twice the length for the same height, roughly half the push. Screws, finer pitch, more turns, more force, less travel per turn. Fast history sprinkle. Archimedes formalized lever laws and described compound pulleys and water screws, 3rd century BCE. Egyptian ramps turned vertical lifting into horizontal pulling millennia earlier. Sailors' block and tackle spread efficient pulley systems across the world's docks and ships. Leonardo da Vinci sketched improved lifts, jacks and screws that look modern. 19th century standardization, Whitworth Sellers, made screw fasteners interchangeable. Why techs should care? Torque drivers and lugs. The screw is a machine. Follow torque specs to get the right preload. Over-torque can damage copper and create hotspots. Clamping and fixtures. Vices and C-clamps multiply force. Align parts so force lines pass where you want them. Moving gear safely. When in doubt, add a pulley or lengthen the ramp. Designed for control, not bravado. Myths to retire. Machines give free energy. They only trade force for distance and time. Work in to work out, plus friction losses. Bigger handle is always safer. Not if the fastener or lug can't take the load. Know the limit. Centisme. Any pulley equals easy. Poor bearings and bad rope angles kill efficiency. Wrap. Simple machines are force traders. Use them to gain control, not to skip physics. Know the trade, more distance, more turns, or more rope for less effort. Thanks to Tony R. Kuphaldt and the open source community. Like and subscribe to Crash Course Instrumentation for more bite-sized lessons.